domestic electric circuit. So my dear students, this will be our topic for today's discussion, domestic electric circuit. So without wasting any time, let me grab my marker and let me welcome you all. So hello my dear students, my name is Banatang Paton and I welcome you all to the channel Classroom where we learn together. So this will be the last topic and let's see how long this video will be. If it is very lengthy, I'll break it into two parts. So in the first part of the video, we will be talking about in detail the different components which makes up the domestic electric circuit. And then let's see, like I said, if it is very long, I'll break it into two parts. So until unless I start teaching, I will not know. So let's see. Okay. If there are two videos, if there is another video besides this, that means that the lecture was too long and I had to cut it into two parts. And if I am able to wrap up in one video, that means this will be the last video. So we are in chapter 12. The name of the lesson is Magnetic Effects of Electric Current, and we have learned a lot. We have learned so many things from this lesson. We have learned about magnetic fields, the nature of magnetic fields, the properties of magnetic fields. Then we have learned about Oyster experiment. Then we have learned about Maxwell's right-hand rule. We have learned that in a carrying conductor there is magnetic field, and now we know how to find the direction of magnetic field. Is it clockwise or anti-clockwise? And then Fleming's left-hand rule, force on a carrying conductor. So much, okay, so much solenoids, electromagnets. So this lesson is truly filled with lots and lots of knowledge. So I believe that you have learned, and then if you have not learned again, then you can always revise. That's the advantage of learning from YouTube. You can always rewind and watch the video so that you learn. So let's continue. Okay, so this is an important topic. It has been asked in the Nagaland Board of School Education NBSc board exam in the past few years. I still remember the mark. The mark was for 3 marks. Why am I writing question 3? I want to write 3 marks. So it was asked for 3 marks, where the students were asked to draw the domestic electric circuit and they had to explain what's going on. So it's an important topic. And then it's very easy to draw this also. But then you have to follow the story. So if you say that you will just memorize and go, then you may have to spend some time. Okay, but I assure you, if you go like a story, then you don't need to memorize anything. It's easy. Okay, you just have to know what's happening to the wires and what each wire does and what they are. That's it. That's the way we learn, isn't it? So we don't memorize. I don't encourage memorizing. I encourage my students to understand the concept. So concept is king. I've been using this phrase in my past videos also. So once again, this word has come to my mouth. Concept is king. Nothing beats concept. So learn the concept. Okay, learn the concept, and once you understand the concept, you are ready to face any question. So learn the concept. So like always, before I start any video, I always request and I always encourage my students to grab a notebook, grab a pen or a pencil to write down whatever is being discussed in the whiteboard, so that it will serve as a helpful notes for you to write in the exam. Okay, so if you have not done that, please grab a notebook and a pen or a pencil and take down the notes. So to start a discussion, I have a question. From where do we get electrical connection in our home? So let's say this is our home. So then from where do we get electrical connection in our home? So electrical connections in our home, my dear students, are brought from wires which are running in the light posts, which are called as the mains. So outside of our home, so we have light posts. My drawings are very bad. Please don't laugh at my drawings. So we have light posts through which wires are running. So these wires are called as the mains. All right. So these wires are called as the mains. Okay. Let me just check whether the screen is in the right orientation or not. So All right, so I have to know how much of the screen is available, because sometimes I zoom out, and sometimes I think it's called zoom out, isn't it, when we go for extreme zooming. So if I zoom out, less of white part for me. If I zoom, yeah, I think zoom in, not zoom out. Okay, if I zoom in, then less of the screen, and if I zoom out, more of the screen, where even the wall will be visible. So I don't want to. I want the screen orientation to fit exactly. So till this much. So it's good to know that. So yes. So where was I? Yes. So mains. So electrical connection in our home is brought from wires called the mains. So these are the overhead wires which are out there in the light posts. Okay, near the streets. It may be in the streets, somewhere in the colony. Okay, go and see. These overhead wires, they are the ones which bring electrical connection to our home. So the electrician brings electrical connection in a home from these two wires. So two wires will enter a home from these, and these are called the mains. Okay, so these are also mains only. Okay, these are mains, and these are attachments of mains only. So now, but then these two will have a separate name now. So this will have a separate name. So one of these wire which brings in the current is called the live wire, and the other will be called the neutral wire. So one is called the live wire and the other is called the neutral wire. The live wire is also known as the positive wire, and the neutral wire is also considered as the negative wire. Now, so electrical connection in our home are brought from wires called the mains. Then another question, so many questions coming to my mind. So another question which I want to ask you is, from where do the mains receive their power, or from where do the mains receive their energy? So anyone who can tell me from where do the mains receive the power, the energy? Who can tell me? Yes. What is the answer? Yes. Yes. The mains, they receive the energy, the electrical energy, from the power stations. So this is the source. This is the source of the electrical energy which is running through the mains, and then from the mains we get the energy. So our house receives the electrical energy from the wires called the mains, whereas the mains receive the energy from the powerhouses. Okay, the hydro dams, the thermal power plants, it can be anyone, but that is the source from where electrical energy is being generated. So now two wires. Okay, now why two wires? One wire is called the positive, the other is called the negative. Now why do we need two wires? Why can't we do electrical connection in a home with just one wire? A very interesting question, and a question which some of you may be thinking also. Yes sir, yeah, why do we need two wires? Why not just with one wire? Let's discuss. What if we take only one wire? So let me show you a demonstration. So I don't have space today. I don't have space also. I can't erase this also. So let me just show you. Let me just utilize this small space that I have. So let's take a battery here. Positive, negative, and let's take a bulb. So this is the bulb. Now one wire. Okay, so let's just take one wire and then let's connect it to the bulb. Now one wire only connected to the positive terminal. Since the wire is connected to the positive terminal, then the electrical current will exit and then it will travel through the wire to the bulb. Okay, so electrical current will reach the bulb because the positive charge will travel out through the wire being a conductor of charge. The positive charge will escape through the wire and it will go to the bulb. Now my question, my dear students, is, and I am sure all of you will be able to answer the question, is will the bulb glow? So will the bulb glow? Will the bulb glow? So will the bulb glow? Will the bulb glow? So will the bulb glow? What is the answer? Definitely not, isn't it? Definitely not. The bulb will not glow. The bulb will not glow. Why? Why doesn't the bulb glow? The bulb will not glow because, see, electrical devices only work in a closed system. Now, what is this closed system? What do I mean by closed system? By closed system, I mean that, okay, the electrical charge has to enter the device, and from the device it has to exit, and then it has to be brought to the other terminal of the power source. So that means we need one more wire. Okay, which will bring the charge which has entered the device back to the battery. This is how we achieve a closed system. Now the bulb will glow. So this is how every electrical appliances and every electrical devices operate. Okay, so electrical devices will only operate when the charge which enters it, okay, also exits from the device into the battery or into the source, whatever it may be. So this is how electrical devices work. So it has to be a closed system and not an open system. So if I remove this wire, then it becomes an open system, and in this scenario the bulb will not work. Okay, so remember, electrical devices will only work in closed system and not in open system. With only one wire, charge will go to the device, but it will not exit from the device. So that's why we need two wires. So I hope you understood why we need two wires. So the same thing is happening to our domestic electrical connection. We need two wires. One wire, which is the live wire, which we consider as the positive, to bring in the charge, and another wire, which is called the neutral wire, okay, to take away the charge. So the live wire, you can see the red one is the live wire, okay, goes to the switch, to the board, to the socket, and then the black wire is here. So now between this and this point, it is the socket. So the electrical devices, the pin of the electrical device will be connected here. So electrical energy will enter the device, and then it will exit the device, and then the exited charge will be carried by the neutral wire all the way back to the mains again. So one wire, so this comes here and this goes here. So the live wire brings in charge, and the neutral wire takes away the charge back to the mains. Just like the charge exits from the positive terminal, and the other wire brings it back to the negative terminal, and a closed system is created. Okay, so if you understand this, you have understood this, why we need two wires. All right, so there I have just explained to you why we cannot do electrical connection using one wire. I hope that you understood. So let's continue. Now let me erase these things and make it more appealing and more easy, and also let me create some room for me to scribble. So now this is the live wire. Then the first component, the first connection that we do with the live wire is the fuse. So let us study about the different components now, and we will start with the fuse. So the live wire is connected to the fuse. Now what is this fuse, and what is the purpose of fuse, and why are we using a fuse? Very, very good question. So what is the fuse? The answer to this question is, a fuse is a safety device. A fuse is a safety device. Make sure that you write down this. This is the shortest definition of a fuse. What is a fuse? A fuse is a safety device. So safety device. So what is it protecting us from? Because we are using the word safety, so it must protect us from something. So what is it protecting us from? So it protects us from overloading. Now then there's a question in your mind, sir, what is overloading? What is overloading? Let me tell you. overloading is when too much current tries to flow through or overloading is when too much current is brought by the wires. Okay, so when the wires bring in too much current, there are many reasons why overloading takes place. We will be discussing in the very soon. Okay, after some few time, our topic will be overloading and short circuiting. So we will be discussing in detail there. But simply, I'm telling you what overloading is. So overloading is when excessive current flows through the wires, which is not good. Now, why is it not good? It is not good because we know Joule's law of heating. So Joule's law of heating, JLH, okay? JLH stands for Joule's law of heating. So we know from Joule's law of heating that when too much current, when strong current, or when a high current flows, heating will take place. Tremendous heating will take place. So when more current flows, more heating takes place. When less current flows, less heating will take place. So because of this, overloading is bad. Because overloading means what? High amount of current flow will take place, isn't it? So current flow will be high. Current flow will be high. Thereby, heat produced will also be tremendously high. Now, what will happen if the wires get overheated? If the wires get overheated, danger, heat danger. Okay, why? Because the insulation upon the copper, the insulation upon the aluminum, which is nothing but plastic, it will melt and it may even catch fire, and the whole electrical circuit, the whole plastic casing running through your room, through our houses, will get burned. So do you want this to happen? Of course not. No, we don't want this to happen. So overloading is bad. So how do we prevent this? How do we prevent this? How do we prevent our wires from becoming overheated? Okay, or simply, how do we prevent excessive current from entering these wires, okay, our home in the first place? So what we can do is we will use a fuse which will protect us from overloading. So a fuse. Now let's learn about a fuse. What is there in a fuse by which it is able to protect us from this situation? So what you need to know here is that a fuse is a small wire, is a thin wire having very, very low melting point. And a fuse is an alloy. Okay, a fuse is an alloy, and it has got one very important property of a fuse is that it has got very, very low melting point. So a fuse has very low melting point. A fuse has very low melting point. Now, how does having low melting point save us from this situation? Now, since it has got very low melting point, when high value of current passes through the wire, the fuse will detect the heat, okay, and then since it has got very low melting point, a slight increase in the temperature is enough for the fuse to melt and break the connection. And that's how the fuse will prevent the high value of current trying to enter through the wires. Okay, how it will now, so that's how the fuse will stop the high value of current which was trying to pass through the wire. So I hope you understood how a fuse protects us from this high value of current which was trying to enter our home. Okay, it detects the heat, and then having very low melting point, it will melt at a slight increase in temperature, and that's how it is able to prevent the high current which was trying to enter our home. And this is how a fuse saves us, and this is why we call a fuse a safety device, because it has just saved our home from the high current which was trying to enter our home. And had it been allowed to enter our home, then what will have happened? Our wires will have got burned and our devices will have gone damaged. So I hope you understood how important a fuse is. A fuse is a very, very important component of the domestic electric circuit. I hope you all got it. All right. Okay. So let's move forward. Then after that, so after the fuse, which is a very important part, comes the meter. So now remember, my dear students, that energy is not free. So we have to pay for energy. So the power department has installed or will install a meter box in your home which will calculate the electrical energy consumed by you or your family, and at the end of every month they will send a light bill which we have to pay. Okay, in our state Nagaland, we go especially, well, in my own home, let me use my own example. So every month the bill comes and we have to go to the powerhouse and pay the bill. So of course online payment is possible these days, but then we prefer, my dad used to go and then he prefers the cash mode, not the online mode. So we pay like that. You can pay online these days, online facilities are available, or you can go and pay cash. So like that. So electricity meter box to calculate the amount of current used by our home. I hope that's clear. Then moving forward, the live wire will now go to the distribution box, which is a very important component of the domestic electrical circuit. So what is this distribution box? So as the name itself suggests, distribution box. So distribution will take place. It's just like my arm, okay? This is one single arm, but see, this arm gets split into 5 fingers, isn't it? So it's just like that. So one single arm and it splits into 5 fingers. In the same way, the distribution box is where the distribution of the live wire and the neutral wire will take place, which is very important, okay, because after distributing, the live wire and the neutral wire can be connected to the rooms and to the different floors of the building. Okay, so in one house, the electrician will only bring one connection of the live wire and one connection of the neutral wire. But using the distribution box, the single connection of the live wire and the neutral wire, which he has brought from the mains, will be distributed into as much as he wants, or as much as rooms are available, or as much as floors are there, so that each floor will get its connection of live wire and the neutral wire, and likewise each room will also get its connection of live wire and neutral wire. So that is the importance of distribution box. In distribution box, the distribution of the live wire and the neutral wire takes place, so that each floor, the basement, the first floor, the second floor, the third floor, will get their own separate connection of the live wire and the neutral wire, and likewise each room can also get its own connection of live wire and neutral wire if needed, with the help of the distribution box. So that is the function of distribution box, which is actually very important. Okay, now between the live wire and the neutral wire in our country India, the potential difference is 220 voltage, which is different for different countries and areas. I don't know about others, but I do know that in USA it's much below ours. I think theirs is around 110, like that. Okay, I'm not very sure, but you can always check it. So in India, the government of India gives us a potential difference of 220 volt between the positive and the, no, not the positive, yeah, we can say between the positive and the negative terminal, or we can say between the live wire and the neutral wire. And then all our electrical devices, whether it's the electric press, the electric iron, fan, or oven, refrigerator, every electrical appliance in India, they operate within this potential difference. Okay, remember this. So now pay attention to this setup, and I want to ask you a question. So if you look at this setup, from here the live wire goes, and then you can see the branching which is happening to the live wire, and you can also look down at the neutral wire and see the branching. So I have a question for you, and the question is, could you tell me what type of connection is happening there? A parallel connection or a series connection? Please tell me, what is the connection which is being used in our domestic electrical circuit by the electrician? Does he opt for parallel connection, or does he opt for series connection? Yes, you're absolutely correct. The connection, the circuit connection which is done in our homes are parallel connection. So this is a parallel connection and not a circuit connection. So see here, the live wire goes here, and then from here it branches out. The same live wire continues here, and then it branches out. The same live wire continues here, and it branches out. So this is series or parallel? Parallel. Okay. Had it been series, it will be like this. Had it been series, it will be like this. It will be like this. Okay, these are the different sockets. So had it been series, it will look somewhat like this. Okay, but here it's not like that. This is parallel. So remember, in our homes, the connection that is done is parallel and not series. Now, why we go for parallel? Because parallel has got more advantage, okay, over series. There are many problems with series. We'll discuss them one by one. Now we go for series. We go for parallel connection, so that each socket, each point in the socket receives the same potential difference, which is 220 voltage each. Point number one. Point number two. Since each socket receives the same potential difference, each electrical appliance will also receive will also work within the same potential difference. That means if I connect here an electric heater, and if I connect here the refrigerator, and if I connect here the oven, then all of these are getting a potential difference of 220 volt each, even though they are being used simultaneously at the same time. This is the advantage of connecting in parallel, which will not happen in series. Okay. And then the advantage of connecting in parallel is that each line can function independently. Means we can always put a switch here, and then if you switch off this also, it will not affect the other two. Or if you switch off this also, it will not affect the first and the third. If you switch off this also, it will not affect the first two. That means each switch, each board, each socket can function independently, and this is the biggest advantage of connecting in parallel. Which, let's try the same thing. Let's see whether this independent function is available in series or not. So we'll just take one example. So this is the first socket, this is the second socket, and the third socket. So now let's put a switch here. So let's put a switch here, and then let's do like this. So let's say this belong to different houses. I hope this is a house. Okay. So house 1, house 2, house 3. Each house receiving one socket each. So there are tenants here, there are tenants here, there are tenants here. Now let's say the tenant in house 1 goes away. Okay, locks his room, closes the light, and goes away. Then so he switch off his connection. Then if he switch off his connection, what about house 2 and house 3? Will they receive electrical connection? Because electrical connection is coming from here, and this fellow has already switched off the connection from his house. So what about 2 and 3? Will they receive current? No, is it not? No, because see, it is off. This is the disadvantage of series connection. In series connection, if the first socket is off, then the other 2 sockets will also get off. They will not get current. So do we want this? No. So in series connection, this is the problem. Okay, this is the problem. Even if you give a switch here also, or even if you give a switch here also, it will serve no purpose. It will serve no purpose. It will not serve anything. It will serve no purpose as long as this is off. Okay, no, but even if they are on also, it is of no use, isn't it? Because it is off here. So I hope you got to know why series connection is not used, and we go for parallel connection, so that each socket functions independently. Even if you switch off this also, okay, only this socket will not be receiving current, the other 2 sockets will still receive current. So this is the biggest advantage, that each socket can function independently, which is not possible in series connection. Another one, because this is an important question, and I think this is a question even in the exercise, is that in series connection, potential difference is divided, isn't it? We know that. Whereas in parallel connection, potential difference is constant. So we offer parallel connection. Okay, so that's it. We have discussed about the fuse, meter, distribution box, and we are and then the parallel connection which has been done. So continuing forward with the discussion, now let's talk about the sockets. There are 2 types of sockets. We call it sockets, or in the textbook it's called circuit. Both are same only. Okay, sockets or circuit. What would you like to call it? Would you like to call this a socket, or would you like to call it a circuit? Okay, they are same. So there are 2 types of sockets or circuits. So we have the lighting circuit. Let's go as per the NCERT textbook, which is called lighting circuit. And we have the power circuit. So what are these 2? So lighting circuit is the circuit where a current of 5 ampere is flowing. So in the lighting circuit, in the lighting circuit, okay, the current flowing is 5 ampere, and in the power circuit the current flowing is 15 ampere. So where is more current flowing? In the power circuit. Okay, now lighting circuit is used for operating those electrical devices which require less current, okay, which have low power rating. So lighting circuit is used for operating those electrical devices which require low power rating. For example, light bulbs, okay, then fans, etc. Again, the examples are exactly as it is given in the NCERT textbook. Now, whereas power circuit is for operating those electrical devices which require high voltage, high value of current. Okay, so these are for operating those electrical devices which operate on huge amount of current. So the current flowing here is 15 amperes. So the electrical devices which are connected will be those appliances which require high current to function or to work. What are those appliances? We have the heaters, we have the geysers, we have the ovens, we have the rice cookers, etc. Okay, toasters, then AC, air conditioners. These are all appliances which require high amount of current to operate. So they are for them we need a separate connection which is called the power circuit or power connection. And for operating devices like fans, bulbs, okay, or playing music and all that, so the Bluetooth speakers and these audio systems, they can be operated, they can be run through the lighting circuit. Okay, so remember these two. So electrical circuit are of two types. One is the lighting circuit and the other is the power circuit. Very important, you have to know that the electrical energy running through the circuits. 15 ampere for the power circuit and 5 ampere for the lighting circuit. Okay, so more current here to operate electrical devices which require more power, less current here to operate electrical devices which require less power. Okay, then even let's say this is your door, and then let me draw myself, or let me draw you. Then the lighting circuit, let's make him a little longer. I'm very poor in drawing, so let's say you are a tall guy. So usually the lighting circuit will be found here, okay, at your shoulder level. It will be around your, suppose this is the door. If I open the door, mostly it will be here. Okay, this is the lighting, where the light, the switches for the lights are there. Okay, then power circuit. For power circuit, where will it be? So let's say this is the door, and let's say this is you, very tall fellow. Then the power circuit will be somewhere here. It will be below. It will be here, towards the down. And yeah, go and check. It will be below the down. The one below the down is for power, and the one at your shoulder level will be the lighting circuit. And then what do you usually connect here? Yes, refrigerator. Your fridge is connected to this power, to the circuit, okay, near the floor. Electric heater. Winter is around the corner, so heater will be connected here. And then rice cooker connection. All these are done in. All of these devices are connected to the power circuit because they require more power. Okay, so I hope you are clear with the two types of circuit. Now, so the live wire brings the so the positive wire is connected to this terminal of the socket. So every electrical socket has got two terminals. Okay, so the one where the positive where the live wire ends will be bringing the current, so it will be considered plus, and the other one will be considered the negative. So the electrical device, our electrical device will be connected to this pin, to this plug. So the electrical devices, the plug on the device will be inserted to this, and then when we insert it, then the live wire which brings electrical energy, current, the current will enter to the device, and after it enters the device, it will also exit from the device, and the exited current will be taken by the neutral wire. So the exited current will be brought back by this wire, which we call the neutral wire. So now the charge will run through this wire, the neutral wire, okay, to neutral wire, and then it will take it back to the mains. So that's how a closed system is created. Okay. Oh, one thing I forgot to tell you. So I hope this much is clear. Okay. Now, just I remembered one more thing, and which is I did not tell you about the color coding. I should be telling you about the color coding. So let me tell you about the color coding. So the live wire, how did I even forget? I drew here, but I forgot. So the live wire gets a red insulation or a red cover. The outer covering of the live wire is red. So by default, the electrician will use red color or insulated wires. Okay, the insulation is the outer cover. Then the neutral wire is given black insulation. So that it will be easier for him to differentiate from which wire positive current is flowing and from which wire the negative current will be flowing. So black insulation and red insulation. But my dear students, the color coding scheme has been upgraded, so there has been some changes. So the new color code you have to know. So you have to know the new color code. In the new color code, what color does the live wire get? So in the new color code, the live wire, can you guess what color does the live wire get? Yes. Who can tell me? Write in the comment box and let me know. What is the new color code for the live wire in the recent updated color scheme? Yes, what color is that? Yes, the new color is brown. The new color for the live wire is brown. Now, this updation has not been done in your NCERT because our NCERT textbooks are quite old. Okay, our NCERT textbooks are quite old, so the updation in the color has not been done. But you should know that the color coding has changed. Now, no more red, it is brown. And then, similarly, they have changed for the neutral wire also. So, neutral wire. The new color code for the neutral wire is, yes, blue. So, no more black, but now it is blue. All right. So in exam, and also I have told my students at school also that I have seen some students study like this. For the live wire, well, since they were using the old NCERT, they used to use red color markers or red color sketch pens and then connect it. And then for the neutral wire, they will use black. And another wire is called the earth wire, which has got the green insulation. So they'll be using green insulation for that. So like this, okay, visually, just by looking at one go, it's easy to know what's happening. So since I don't have green marker, I could only use red for the live wire. Okay, black, luckily this is black, and green I don't have, so for earthing I used the same black. But like this, okay, you can always find ways and means to study by which it is easier to learn. Okay, so color coding done, then types of socket also done. I hope I'm not forgetting anything. Okay, so now let's continue our discussion further, and then now we will be talking about earthing or earth wire. So another very important component of the domestic electric circuit is earth wire or and earthing. Okay, so let's first talk about earth wire. So what is earth wire? So the earth wire is usually a third wire, okay, which is connected to the third pin of the electrical socket. So our electrical socket, they have got 3 pins, 1, 2, and this one, which is quite big. The circle is bigger than the other two. So the earth connection, the earth wire is connected to this pin. Okay, this is called the third pin of the socket. So another wire, a third wire, which is connected to the third pin of the socket. This wire is called the earth wire. And then the insulation of the earth wire is green. So the earth wire has got green insulation. And then remember, my dear students, that the earth wire has got no relationship with the live wire or the neutral wire. Okay, it doesn't affect the live wire, it doesn't disturb the live wire, so it has got no relationship with the live wire or the neutral wire. It has got nothing to do with the live wire and the neutral wire. Okay, so its connection is done externally. As you can see, it starts from the third pin, okay, and then it will not touch the live wire, okay, and then nor will it touch the neutral wire, and then it will have its own dedicated pathway to the earth. So now it is called earth wire because it has got a direct connection to the earth. So now let's learn about the earth wire in detail, like how is earthing done, like what is the procedure to do earthing, and then why is earthing important. So earthing is done like this, my dear students. So this earth wire will be buried underneath the earth. So usually how we do is, on the ground we dig a pit about 2 meters. So let's say this is the pit, okay, this is the ground, and on the ground we will dig a pit. This is a pit which is about 2 meters deep, and then what we do is, so let's say this is the wire, this is the wire, the earth wire, coming all the way down from our building. Now the end of the earth wire will be connected to a copper plate. So it will be connected to a copper plate. So let's say this is the copper plate. It will be tied, it will be connected to a copper plate. You can wind it over the copper plate, you can tie it. So the end of the earth wire is connected to a copper plate, and then what we do is, we will take salt and we will take charcoal. So a mixture of coal and charcoal will be poured on this. Okay, so charcoal and then salt. A mixture of charcoal and salt will be prepared, and then it will be poured, it will be thrown on this setup, and then later it will be buried with earth. Okay, it will be covered by mud, soil, and that's how earthing is done. Okay, so this part you can also draw like this. So this is the symbol for earthing, and this is how we do earthing on the ground. Okay, so the wire which comes from this third pin will be buried underneath the earth, and how it is buried underneath the earth I have just explained to you. Okay, how it is done. So now earthing is done 2 ways. Okay, it's not written like this in the textbook, but then I teach like this, that earthing is done 2 ways. One is on the socket, which we have done. In the socket, it's simple only. Bring a wire, connect it to the third pin of the socket, and then take it down to the earth. Okay, that's it. Now the other part, it has to be done on the device. It has to be done on the electrical devices. So let's talk about how electrical devices are earthed to understand earthing better. So now see, why should electrical appliances be earthed? Now electrical appliances should be earthed. See, sometimes electrical appliances may have faults in them. So they may have faults in them. Now what do I mean by faults? By faults I mean faulty wiring. Okay, faulty wiring here means, like, say, because of wear and tear, because of continuous usage, and because the appliance is old, and let's take the example of an oven. So let's say you usually keep the oven in some place, and then whenever you require the oven, you bring it to the table and then you operate it, and then you will use it, and then after some time you will repackage it and you will keep it like that. So let's say you bring it up, you use it, and then you keep it somewhere else like that. So there is constant usage, and then at the same time you will repackage it and keep it somewhere like that. So this, okay, not keeping in one place, but then continuous movement is going on with your oven. What will happen? In some cases, what happens, because of this continuous motion, the wirings inside the oven may be, especially the live wire, the insulation on the live wire may get exposed. So let's say the insulation on the live wire is exposed. So let me just draw an oven. I'm not good at drawing, but let me try my best to draw an oven so that we can understand better. So let me draw here. So let's say this is the oven, and we know that the oven has got metallic part. So this is the metallic part of the oven. Now the live wire is here, and then the neutral wire is here. So two wires, one is the live wire, that is a neutral wire. Now what happened is that because of wear and tear and because of motion, okay, what happened, the live wire, the insulation of the live wire is exposed. So the covering of the live wire is exposed, and then it is touching the metallic part of the oven. You are not aware of it, I am not aware of it, and then while using the oven, I kept my hand over this metallic part. What will happen to me? What will happen? Chatka, isn't it? I'll start dancing, isn't it? I'll be starting to dance. I'll be getting, so what is this? This is me getting zapped. This is me getting electric shock. So what's happening to me? I'm getting a nasty electric shock. Is this good? No, isn't it? It's not at all good. It is not at all good. So how do I prevent this? Now this is a very lethal and a very dangerous situation, and I don't want any of us, and I don't want anybody to go through this situation. But mind you, my dear students, people have died. Okay, people have died from these reasons. So it is very dangerous, and then especially with high power appliances like the oven, it is very much lethal because the oven is connected to the power line, and a current of 15 amperes flows through the oven. So just remember how lethal is it. Okay, a tremendously high current flows through the oven. So this is life threatening, and this is not good. Okay, so how do we prevent this? Is there a way to prevent this? The answer is yes, my dear students. We can stop this, we can prevent this. Okay, we may not be able to stop it, but we can prevent this. There's a way by which we will not get electrocuted. So how do we do this? The solution to this is earthing. So the electrical appliance has to be earthed. So how will earthing be done? So what the company will do, what the manufacturers will do is that they will use one more wire, okay, the third wire, which is called earth wire, and the earth wire will be directly connected to the metallic part of the oven. So this is the metallic part, so another wire will be here, and it is connected. So the connection, this is the earth wire, this is the earth wire, this is the earth wire on the device. In the socket, we have already done it. On the device, okay, on the device also is there. So now you know that ovens and all, they have got a 3-pin plug. So I have one here. I have my own not heater, sorry, this is a plug of a heater. So this is called a 3-pin plug. Okay, you can see one of these two are the same size and same diameter, okay, same length also. So from one terminal, current will enter, from the other current will go out, and that's how a closed system is created. And we are talking about this fellow, this bigger in size, longer in size, thicker in size. This is the earth connection for the device. So this device, this iron has got earthing, and even this symbol is seen here. This symbol, I can see this symbol here. Okay, yeah, I may not be able to show you, but it is there. So even the symbolic representation is done to remind me that this is earthed. Okay, not these two, yeah, voila, this big pin, okay, which will enter the third pin here. Okay, voila, this is earthing. It is done in high power appliances like iron. So it will go to the 3-pin plug. So we have 3-pin plug. So we have 3-pin plugs like this. So we can say we can bring it here, we can bring it here, and this will go all the way here. So like this. Okay, this is how the oven is now earthed. This will be done by the company. The company will give you. So my iron has been earthed. Inside the iron, this mechanism is going on. Okay, now what I do is I want to use this oven, so I connect it to the socket. So I'll connect this to the socket, switch it on. Now remember, the live wire is still, this is the live wire, is not this is a neutral wire. The live wire is still in direct contact with the metallic part of the oven. And then again, I keep my hand here. Now I keep my hand here. Now will I get electric shock? Will I get the same nasty shock which I got? Okay, I don't know. Is this the way you get shock? I don't know. Okay, but that's how I'm doing it. Okay, so will you get the same shock? Okay, the answer is yes or no. Will I get the same shock again? No, this time I will not be getting shock. But how? Kaise na? How will I not get shock? How will I not get shock? See, remember, there are two things you have to remember here. Is that current hates resistance. First of all, current hates resistance. Current hates resistance. R. Current hates resistance. Resistance is the biggest enemy of current. Now, see, there is current flowing. There is current flow. Since the positive terminal is connected to the metallic part, my hand is here. My hand is here. I don't know. Can I draw my hand? Yeah. So my hand is here. My hand is also here. And this earth wire is also there. So now current gets two paths to travel. It can either travel through my hand or it can travel to the earth wire. Now current will select the earth wire and not my body. Why? Because I offer a strong resistance. My body, my biological body, your biological body offers a stronger resistance than earth wire. So earth wire offers less resistance. Remember, earth wire resistance is very low, whereas our body resistance is very high. So current will choose the earth wire over our body because current hates resistance. Clear? Because current hates resistance, current will not choose your body, current will choose the earth wire. Point number one. Another point is that the potential of the earth wire is almost zero. The potential of the earth wire is almost zero. That means the potential of the earth is almost zero. Okay, the ground is almost at zero potential. Having zero potential, it will pull the current more towards itself than our body. Okay, so the potential of the earth is almost zero, thereby current, this earth wire will pull the current more towards itself. So now current, for these two reasons, current will not travel through our hand, current will travel through the earth wire. And this is how earthing has saved us from getting a nasty shock, okay, and has prevented me from getting electrocuted. It has saved my life, though the live insulation is exposed and it's making direct contact with the metallic part. I don't get electrocuted, okay, all thanks to earthing. And this is how earthing, this is why earthing is very important, and this is why earthing should be done. And like I said, the company will do it for the device, okay, but you have to do it for your home. So when you build a home, make sure that you do earthing. Okay, these days, unlike olden days, okay, in the olden days, I don't know, maybe some people may say that may not have done, but those days are gone now. Everybody does earthing. Okay, so I guess the video is quite lengthy, so maybe I'll end this video here. Okay, so what have we learned here? What have we learned today in this video? We have learned about the domestic electric circuit. We have learned from where the electrical connection is brought in our home. It's brought from the wires called the mains, and then we have studied the different components, which is the fuse, the meter, the distribution box, and then the switches, the two types of switches, the 5 ampere, which is the lighting, and the power circuit, which is the 15 ampere. Then we have just finished discussing the earthing, the earth wire and the earthing. So I hope, and then just now, okay, we have talked about how earthing saves us from getting the nasty shock which could have killed us. So I would like to end the video from here, and so another video will be uploaded on which we will be talking about short circuit and overloading. It will be a short video, but then like I said, too long also not good. So I'll end the video from here, and stay tuned and make sure to watch the next video. So until then, take good care and God bless you all. Peace out.